Once again, welcome to this webinar where we'll take a look at how we can make sense of big data spatially. In other words, we'll see how you can detect patterns and trends from your massive volumes of data, to see how you can tackle old problems and create a new starting point from which you can begin further analysis. We'll take a look at what is ArcGIS Big Data Analytics, what are the new analytics capabilities in 10.5. We'll also look at GeoAnalytics in action, what is the architecture, and of course, some question and answers. ArcGIS has a new way of processing vector, tabular, raster data with both spatial and temporal components that is designed for fast distributed analytics and storage. And it is delivered as tools in ArcGIS GeoAnalytics Server and ArcGIS Pro. The workflows are similar to what you would use in spatial analysis, and user experience is available in familiar user interfaces like ArcGIS Pro or the portal map viewer. And for the developers out there, through developer interfaces using Python, either through ArcGIS Pro or Python notebooks. So what kinds of scenarios would you likely need to go from noise to intelligence, where detecting patterns and trends would be important? They range from transportation planning and management, where vehicular or commuter traffic modeling from past and existing traffic data could show important patterns and trends. Or it could be in environmental assessment and planning, where you could be collecting census information to identify, for instance, heat islands for green infrastructure planning, or determining solar suitability based on mean rainfall, temperature, land cover, and elevation information variables for extensive areas. Be in commercial sectors, where you could use the patterns and trends for footfall traffic or crowd monitoring. At 10.5, ArcGIS introduces 11 new tools to help you. The focus at this release is on summarizing and aggregating your big data into meaningful insights to understand what is happening. So in terms of summarizing data, you have tools like aggregate points, join features, reconstruct tracks. And in terms of analyzing patterns, there are out-of-the-box tools like calculate density, finding hotspots, or even creating space-time cubes. Let us take a look at GeoAnalytics in action. We'll be looking at the transportation sector to see if there are any patterns and trends that can be derived from 60 million raw taxi pickup records over a period of 1 week. The issue with large data volumes is that visualizing this means you're just waiting for the data to draw without being able to see any patterns emerge. To find any possible patterns or relationships, one way is to do a simple aggregation. You'll notice that there appears to be high activity, not only in the central region, but also in Hougang, Geylang, and Kallang. Would you be able to say that this has always been the pattern? And how did we do this? What we have done is to use the GeoAnalytics summarization tool, aggregate points, to aggregate the information 60 million records into bins. When you open the tool, essentially what you need to do is actually point to your big data store, select it, and input all the necessary information to do an aggregation calculation. Or instead of aggregating into bins, I could also aggregate into the subzones of like housing estates and planning areas. With these, some patterns begin to emerge, and you can begin to explore if the patterns are different from what you would expect. Let us take a look. For example, you may notice that there appears to be a higher pickup rate in the dark red areas along this whole corridor. But if you remember, This corridor actually has a pretty well-developed public transportation system, which includes MRT, and it also has a dense number of bus stops. This additional insight could prove useful as an impetus in considering other factors that may have generated or attracted all these additional taxi trips. You could also, of course, further enrich your analysis by including age or income distribution factors to see if they play a part. Of course, I could also look at the data in another way. I could use the calculate density tool to look at the distribution. From this, what you notice is that the purple areas are actually a sign of high density of busy taxis at 8 a.m. So potentially all the light blue areas indicates that everyone else should be able to grab taxis. You can use these initial patterns as a springboard for further analysis. For example, would there be any correlation between higher pickups and the number of taxi stops? Would age or income distribution play any part in influencing preferences for transportation modes? I could also try to find if there are any time periods where taxi drivers have to make longer trips. With the reconstruct paths tool, the 60 million records have been collated by taxi IDs and the time periods of the day, where these travel patterns were extracted. If I do a playback, what you perhaps could notice is for the pink areas, these indicate the longer trips, and the longer trips appear to occur during the early or during the midday period. Would this mean that the taxi drivers are actually spending a significant part of their time during these hours to cruise for passengers, making longer trips? Would the increasing introduction of information services over the years, for instance, like cab hailing apps, make any impact on these patterns? Would the quality and service be affected as well? All of these outcomes are useful, not just for the planners, but also for anyone else who would like to understand and gain some insights from all the avalanche of information that we are getting. Let me just hand this back over to Anjush. Sure.
Thanks, Hui. So what Hui showed us was how you could leverage on some of the COTS capabilities inside ArcGIS Desktop to connect to your big data repository, analyze the data, aggregate it, and understand the patterns in it. However, like we said earlier, data is important, but it's not as important as the answers it provides or the stories that it tells. So today, your big data analytics is not just restricted to desktop analysis. The ArcGIS Enterprise platform comes with new analytics tools for data visualization. And I'm going to show you one example, which is called Insights for ArcGIS, that allows you to explore this aggregated data within your desktop environment. Could it be on your tablets or otherwise using a simple browser? So let me just quickly show you how it looks like. So what you see here is basically the new Insights for ArcGIS that allows you to perform iterative spatial analytics using maps, charts, and graphs. So let me just quickly connect to the data that he's talking about. So here I'm connected to my GIS portal using my credentials, and I'm able to access all that data that Hui was able to run her analysis on. So for example here, let me just add the aggregated taxi information. So in the earlier example, we saw how we were able to connect to ArcGIS Pro and aggregate 60 million taxi records to derive insights and patterns. What I'm going to be doing here is to be able to dive a little bit deeper to explore some patterns in this data and answer some of the queries that we had brought up. So here you can see that I'm able to seamlessly add in 10 million aggregated taxi records. So let's just take a look at it here. So what it's doing here is it's actually connecting to my big data store. This could be on Hive, HDFS, or any of your raw CSV data sources. So what you're seeing here is actually the aggregated data. So let me just zoom in a little bit. So you can actually see the blue areas are the ones with lower pickups and the yellow areas are the ones which have a higher intensity of pickups. Now, it's not just about visualizing the data as it is. What I can do is I can actually take that data, I can visualize it in the form of a map or in the form of a chart. So I'm going to create another map visualization of the same data, but with the ability to show me more trends. So what I'm going to do here is, rather than going for the default visualization, what I can do is I can actually choose that I want to see it by counts and amounts so that the patterns are a little bit more obvious. I can not just do that, I can actually apply a filter on my data so that it'll show me the areas where the trends are more prominent. Like for example, I want to apply a filter on my taxi population to show me only those areas where I have more than 1,000 records. So I'm just going to apply the filter here. So it'll help me to filter out all the noise and apply a symbology that's going to help me to filter out just the key records where I can understand which are those areas where I have a higher intensity of pickups better. Now, I don't need to just visualize this data in the form of a map. I can also add in a chart. So here I'm just going to create a simple chart that is going to show the trends over time. So there you go. Now you can see that I have a new map visualization that is able to give me the insights in a much better, much more interpretable fashion. Let's see, where did our chart go? Let me just add it one more time. So I can add it in the form of a map, or I can add it in the form of a chart. So in the interest of time, let me just show you a pre-prepared map that I have where I've already added the data in the form of maps as well as charts. So here you can actually see it's the same data. So we had our 60 million aggregated points. You can actually see it in the default visualization. I can see it in the form of statistical counts that are showing me which are the ones that are above and below average. And not only that, I can also leverage on heat maps so that I can understand the clustering of the data better. Now, as I mentioned earlier, it's not just about visualizing the data in the form of maps and graphs. I can also add in statistical information. In this example here, what I did was I quickly added a chart that shows the trends over time. So you notice as I'm able to move my cursor over different times, the heat maps are of varying intensity. So I can actually zoom in a bit further to understand what are the patterns in a specific area. And as I zoom in, what it is doing is it's actually going back, querying the 10 million records and regenerating the patterns on the fly. So I can understand what is the distribution over different times of the day. For example, I want to understand the distribution at 5 o'clock in the morning versus 6 to 8. This is when most of our office workers are moving out. Whereas what is the time during 12 and towards the end of the day in the afternoon and so on. So you see, each time it's actually able to query the data and dynamically generate these insights that help me to better understand the traveling patterns. Now, GIS is not just about seeing dots and heat maps. It's also about being able to understand spatial patterns in the data. So here what we'd like to show you is another example of using a COTS tool, which is called as the Emerging Hotspot Analysis. You see the same map with the 60 million records aggregated, but now you see that the different colors mean different patterns. Like for example, the dark red colors imply this is an area which is a persistent hotspot. So what we do here is that we run an emerging hotspot analysis by binning the data over space and time to understand what is the pattern in that particular area. So this area is an area where there's always a large number of pickups throughout the day. The lighter red are the areas where there's a lower number of pickups during certain times and then intensifies over the day. The blue areas are the ones where you have kind of like there's not much change, and the others, the gray areas, where there's no significant patterns. So what it immediately allows me to do today is that I'm able to quickly understand these are those areas where I have a very strong consumer behavior. And instead of just seeing it as a map, I can actually see it in the form of a bubble chart, which is interactive. So let's say if I want to focus on the areas which have persistent pickups, very high number of pickups, I can click on the bubble here. It'll actually highlight which are those areas. And I can also see which are those, like Changi Airport, you have certain areas around Jurong at certain times of the day and so on. Now, not only that, what I'm also able to do is I'm able to actually overlay information that is related to my subzones. For example, here in this data, I actually have age-related data. So what I can do here is I can actually quickly add a chart that shows what is the distribution of people between the age of 40 to 44 who are making use of these taxi services. So I can actually click on the chart to understand, is there a certain pattern in their behavior? Like for example, areas where you have a higher number of people who are in the middle income group, what are their behavioral generally? So if you look at it, it's mostly around here, it's sporadic, not emerging and so on. I can compare this against, for example, if I'm looking at more elderly population. So here, if I look at areas where I have a higher number of elderly, you can actually start to see some patterns emerging. You see that it's persistent, consecutive, and intensifying for areas where you have more elderly. So does that mean that definitely in areas where you have more elderly, there's a higher chance of taxi pickups? And then the other part is also we would like to do a correlation analysis to be able to understand, is there a relationship between areas where you have higher number of elderly and higher number of probably office workers in the age of 40 to 44. So for this, I can leverage on my statistical charts. So I can apply to check whether there's a linear relationship between them. So here I'm using a scatter plot that actually shows the distribution of data and also helps me to calculate the coefficient. So you can see that the coefficient here is like 0.87, which indicates that yes, there's probably a higher correlation between the rate of taxi pickups in areas where you have more elderly and people within the range of 40 to 44. So this is kind of like, so this is just one example. Age is just one of the factors. The other example could also be related to dwelling types or household income and so on. So what this basically allows me to do is that it allows me, for example, as a taxi operator, to understand which are those areas. For example, after a taxi picks up or drops off a passenger, where is the next best place he can go to so that he can be assured of another fare rather than randomly selecting the next location that he wants to go to. As, for example, a transport operator, I would like to understand some patterns on these areas which have a high number of pickups. Is it because of poor public infrastructure there? Or is it like we said, those areas are all well connected by MRT? So is it something related to the demographic profile? Are there not many elderly friendly facilities available for public transport in those areas? But regardless of this, the nature of the problem you're trying to resolve, what you're able to see here is that I'm able to quickly connect to my data sources, aggregate it, and then leverage on tools like insights to dive deeper into the data to get better understanding and make better decisions. Over to you, Hui. So what we saw just now was how we could leverage on visualizations tools like Insights for ArcGIS to help us to rapidly perform spatial data exploration, to understand data, ask questions, and get better understanding. So now I'm going to just turn the time over to Hui so she can quickly take us through a quick recap of the function.
Thanks, Ajusha. So why would I want to use GeoAnalytics? It lets you extend your desktop with high performance analytics. It's applicable to anyone with an ArcGIS desktop. It helps you get the big jobs done faster. It's applicable to anyone performing automated regular analysis on large datasets. And it's fully scriptable in custom solutions. GeoAnalytics is out of the box and ready to use within your ArcGIS system. Taking advantage of geo-distributed analytics and storage lets you cover it in geoprocessing, adding the power of GeoAnalytics and giving you the standard output into your portal where everyone can share the analyzed information. Let us take a look at the architecture for this. GeoAnalytics Server is an extension of ArcGIS Enterprise that enables our users to register big data sources such as Hive, HDFS, and use Spark to perform the GeoAnalytics. The results are saved into the data store. So what kinds of inputs can you actually use with the GeoAnalytics tools? At this point in time, you can use what is called a big data file share. It is essentially a collection of files, which can be CSV files, shape files, represented as one data set with the same schema. In other words, you can attach your existing big data stores to the GeoAnalytics tool sets. In terms of output, the analytical outputs are actually hosted feature services, and by default, these results are shared into the spatial temporal big data store. If you run a space-time cube analysis at this point in time, it will give you a local net CDF file, which you can still share with your other colleagues. So in summary, the focus at this release, 10.5, is the 11 tools that are used mainly on summarizing and aggregating your huge data volume sets into meaningful insights to understand what is happening. And with that, we have come to the end of the webinar. So in summary again, the big data analytics, why would you want to use it is that it helps you reduce your costs. It helps you increase values because you can process massive data collections. And of course, all in all, it helps you to solve problems by helping you to discern spatial and temporal trends simultaneously. And with that, we have come to the end of this webinar. You're welcome to post any questions that you have, and we will take any questions and answers now.
Yeah, so here we have a question on what is the best practices to organize or structure big data repository so that analysis can be performed. And there's also another one here that's talking about, are there any plans to combine insights for ArcGIS and big data processing functions into a single view? So coming to the questions on the organizing the data in the big data repository, today, in terms of the best practices, what you could do is depends on the volume of data that you have, and at the end of the day, what is the kind of analysis that you want to do. So today, as per the architecture that we showcased, you can leverage on your existing big data repository if you already have it. So one of the key things is if you want to leverage on the best of both worlds, where you want to leverage on the query processing or the parallel processing in your existing environment, you just need to organize your data into Hive tables or Hive views that actually have a location coordinate that can then be geocoded inside the ArcGIS path. And we can leverage on all the other tools and services, because essentially it's a service-oriented architecture. You'll still be able to mash both these dynamically inside both Insights as well as ArcGIS Pro. Regarding the ability to be able to understand both functions, I think today we do have the ability to run some of the aggregation tools using Portal for ArcGIS. So how I interpret this is that you would like to be able to run on some big data processing functions on a browser view rather than half on desktop and half on browser. So today, yes, it does allow you to do that. But like we said earlier, it also depends on what are the kind of questions that you want to ask of your data. Like today, if I wanted to process all my raw data, that could be a few billions of records, I would still run it onto a desktop environment, which is more stable or with localized data as opposed to pushing everything onto cloud. Of course, today, if I have a very strong cloud computing environment with microservices and instances that can be spun up quickly, yes, that would be a better environment. Do we have other questions? Okay, well, So before we end, just some quick announcements. So I'd like to cordially invite all of you, that especially those that are in Singapore, to please join us for our meetup on Big Data GeoAnalytics happening at the Esri Singapore office on 31st March at 4 p.m. So this is where we're going to see a great mix of users coming down to actually share what are some of their use patterns. We will have our experts on standby who can actually show you some hands-on on how some of the tool works, and happy to hear from you on the challenges and queries that you may be having. Our next webinar is going to be on apps for everyone. So the registration link is already up. So today, one of the things about Esri as a leading spatial platform, it's not just about providing tools and technologies and capabilities. The Esri platform today comes with hundreds of ready-to-use apps that allow you to quickly capture your GIS data, analyze it, and disseminate it. So do join us for the next webinar on apps for everyone happening on 14th of April. The registration links are up, so you can go to the Esri Singapore website at www.esrisingapore.com, and under the events section, you'll actually see the information on all the upcoming webinars and meetups. So please do register. Well, that brings us to the end of our webinar. Thank you for staying with us. If you have any technical queries, you can write to Hui. Her email ID is here on the screen. For general feedback, please write to me if there's any other topics that you'd like to have us present in our future webinars or meetups. For commercial and sales discussions, feel free to write to us at connect@esrisingapore.com.sg. Thank you all for staying with us, and wish you all a great week ahead. Thank you.